Unit 2, Lesson 1, Compound Units. Units named using the product or quotient of two or more simpler units are called compound units. We studied compound units back in Unit 1 when we were introduced to rates. So remember we talked about things like miles per hour, and it involves both distance, which is measured in miles in this compound unit, and time, which is measured in hours. You can perform conversions among compound units as well using unit analysis. Now, one thing to note, when we talk about miles per hour, we usually just write mph. But if you are going 55 miles per hour, what that means is you are traveling 55 miles for every 1 hour. So you can write that compound unit or that rate as a fraction. So keep that in mind as we're working through these two examples. In example 8, we're told that a drum of oil contains 62 gallons and it cost $175. So this is our given information. And we're asked to find the cost per pint. So remember we talked in class on Friday, one of the first things you'll want to do when you're doing unit analysis is to identify where you want to start, where you want to end, and how you're going to get there. So the start is usually your given, and the end is usually what you're asked to find. So you're looking for the question. And in this case, we are asked to find cost per pint. So if we think about how we wrote miles per hour, we could write cost per pint as cost over pints. So remember the word per means to divide, and remember the fraction bar is a way to symbolize divide. So if we want cost in our final answer in the numerator, then with our given information, let's put cost in the numerator as well to set us up where we want to be. So this would be 175. Don't forget your units. This would be dollars over 62 gallons. So let's think. This one is challenging because we're not really converting the top at all. We're given dollars and we want to find the cost, and that will also be in dollars. So what this problem presents is we are going to actually use unit analysis not to convert the numerator, but this time to convert the denominator because we want to go from gallons to pints. Now we're not going to be squaring or cubing anything in these because we're not talking about area or volume. We're just talking about a rate. Let's go back to our conversion chart and see how can we go from gallons to pints. That's liquid capacity, so let's see. We can go from gallons to quarts using 4 quarts in a gallon, and we can go from quarts to pints using 1 quart is 2 pints. So let's go back to our problem. So our conversion factors are going to be 1 gallon is equal to 4 quarts, and 1 quart is equal to 2 pints. All right, so now we're going to start our unit analysis by starting with our given $175 over 62 gallons. We're going to need 2 more fractions to do this, and we want to use this one next. But now our alternating units are going to go from the bottom here to the top. So if we have gallons in the bottom, we want gallons in the top. So we'll put 1 gallon over 4 quarts. And now the gallons will be gone, and our alternating units will go from quarts in the bottom to our conversion factor in the top, which is 1 quart over 2 pints. Now, if I had written these upside down up here, it's okay. We can just flip them if we need them to flip. The thing you need to remember is these alternating units, so they'll cancel out. So quarts are going to cancel here, and we'll be left with dollars on the top, which is what we wanted, cost, and pints on the bottom, which is what we wanted on the bottom. So now we're going to do the math, finally get to think about what math we're going to do. So on the top, 175 times 175 times 1 times 1 will give us 175. On the bottom, you're going to do 62 times 4 times 2. And if you multiply those together, you get 496. And this is dollars, and this is pints. But we usually want a unit rate. So to get the unit rate, you're going to divide. Remember, we did that back in lesson 1. So 175 divided by 496 is going to give you 0.3528. Da-da-da-da-da-da. Now they ask us to round to the nearest cent, which is the hundredths place. So that's the second decimal. Usually when you're doing money, you're going to round to 2 decimal places. So we look next door. That number is not 5 or bigger. So that's going to stay a 5. So it's going to be 0.35 dollars per pint, which we'll symbolize with the dollar sign, and then you usually put the per, and then it's 1 pint, but you normally don't write the 1. It's just understood to be a 1. So our answer is $0.35 per pint, or 35 cents per pint. But if you're using cents, you wouldn't have the decimal place in there. All right, so that's example 7. Let's move on to example 8. I'm sorry, that was example 8. Let's move on to example 9. So in this problem, we're asked to convert 5,200 feet per minute, and we want to convert the units to miles per hour. So let's write these as fractions. 5,200 feet over 1 minute. And we're asked to convert these, and I'm going to put this over here, to miles per hour. So this is the most involved problem we've worked so far, because if you notice on the top, we need to go from feet to miles. And on the bottom, we're also converting. So we're going to go from minutes to hours. All right, so this is going to be our start. This is going to be the end. And then our conversion factors to get there. If we go back to our conversion chart, we do know that there are 5,280 feet in 1 mile. And we're asked to go from minutes to hours. Well, hopefully you all know there are 60 minutes in 1 hour. And I think that was on the front page of our notes up here. Yeah, we have our time here, but most people know these by heart. Okay, so our conversion factors are going to be 5,280 feet is equal to 1 mile, and then 60 minutes is equal to 1 hour. All right. So now using our string, we're going to start with our given 5,200 feet over 1 minute. Now it really doesn't matter which you convert first. I normally convert the top first and then I worry about the bottom. So kind of one step at a time. So this is what we want to use next if we're focusing on feet. And in this one, we want feet to go on the bottom and the 1 mile to go on the top. Because remember, we want those alternating units, so we have feet to feet down here. So our feet will cancel. We're at miles, which is what we wanted to have. So our top unit, we're done with. So now we can change our focus to the bottom. Now, one thing you need to understand is that something here can also cancel with a fraction over here. It doesn't have to be right beside it. So we're going to just keep this string going, but now we're going to focus on getting rid of minutes. So we're going to use this one next. And the minutes, where would they have to go? Well, if minutes are in the bottom here, they're going to have to go on top in this fraction. So I put 60 minutes on the top and then 1 hour on the bottom. So the minutes will cancel with this minutes. I'm left with hours, which is what I wanted. So I'm done with my unit analysis string. So now I need to do the math. So on the top, I'm going to do 5,200 times 1 times 60. And on the bottom, I'm going to do 1 times 5,280 times 1. Now, you don't really have to write the times 1 because multiplying something by 1 doesn't change the value, but I just do it so we don't get confused. All right, so now on the top, 5,200 times 6 is equal to 31,200. On the bottom, we have 5,280. And now we're going to do in our calculator 31,200 divided by 5,280. And that gives me 5.909. Now it does go on. So let's see where they want us to round to. It says the nearest tenth, which is the first decimal place. So if I go to the first decimal place and I look next door, that is not 5 or bigger. So it's going to stay a 9. So it's going to be 5.9 miles per hour. Or we can write this as mph. So we learned in lesson 1 we can use unit analysis to convert just one unit. We can use it to convert squared and cubed units. You just have to be careful. If you're using it to convert squared or cube units, remember, you've got to create those new units, so be careful about that. And then finally, we learned in Unit 2, Lesson 1, that you can also use it not just to convert the top unit, but also the bottom. And in example 9, we converted both. Let me know if you have any questions.